This is question 87 from section 1 of the 2018 NSAA paper. So, in this question we're given these two horrible expressions. The integral of x to the n between 0 and 2 with respect to x is 16 root 2 over 7. And the integral of x to the n plus 1 between 0 and 2 is 32 root 2 over 9. And given all of this messy information, we're asked to find the value of m. So, we've got these two equations here. First things first, let's get these to a better form. The integrals essentially make these, you can't really work, they're unworkable, you can't really do anything with them. So let's get rid of them. So let's evaluate it. So 1 becomes 1 over n plus 1 x to the n plus 1, with the limits 2 and 0 put in, is equal to 16 root 2 over 7. So bring the 1 over n plus 1 out, and we get 2 to the n plus 1, minus 0 to the n plus 1, which is 0. That's equal to 16 root 2 over 7. And getting rid of 0, we get 2 to the n plus 1 over n plus 1 is equal to 16 root 2 over 7. Now for equation 2, we can do a similar thing. Get 1 over n plus 2, x to the n plus 2, we're evaluated at 2 and 0, is equal to 32 root 2 over 9. And once again, by the same method as here, we get 2 to the n plus 2 minus 0, so we just ignore that, over n plus 2 is equal to 32 root 2 over 9. So we've got these equations in a better form, i.e. without the integrals, and hopefully we can work these to something useful. So how are we going to solve these equations? Well, the clearest way to do it is probably substitution. So if because we can write 2 to the n plus 2 as 2 times 2 to the n plus 1, right? So if we can substitute 2 to the n plus 1 in, we'll just have an equation in normal m's without powers, and we should be able to solve that. So equation 1 becomes 2 to the n plus 1 equals 16 root 2 over 7 times by n plus 1, by just making 2 to the n plus 1 the subject. And then we can sub 1 into 2, right? And just get an equation, a normal equation in m, where nothing's to the power of. So we get 1 over n plus 2 times by 2 times 2 to the n plus 1, right? So this is the 2, and this is the 2 to the n plus 1. We want to sub in 16 root 2 over 7, lots of n plus 1. And we know this is equal to 32 root 2 over 9. Now, this looks a bit of a mess, but a lot cancels. So you'll know that 16 times 2 is 32, right? So this will just cancel with this 32. And similarly, we can get rid of the root 2's. And then once we've cancelled all that and rewrite our equation, we get to this. So we get 1 over 7, lots of n plus 1, equals 1 over 9, n plus 2, where we've just times through by the n plus 2. And this is fairly easy to solve. Let's times through by 9 and times through by 7 as well to get rid of these fractions. We get 9m plus 9 equals 7m plus 14. Take the m's over, take the constant over, 2m equal to 5, and m is equal to 5 over 2. So this is our value for m, what we're asked to find. And this corresponds with E in the multiple choice, so our answer is E.